Welcome to the Resilience Advantage, a series brought to you by the U.S. Resiliency Council and Optimum Seismic. I'm your host, Evan Reese, and we're exploring what resilience means to our communities in the face of natural disasters like earthquakes, hurricanes, floods, wildfire, and now even pandemic. In this episode, we'll discuss the social and economic benefits of designing new buildings to not only be safe during natural hazard events, but to limit damage and recovery time. It's essential to the resilience of a community, a business, or a family that the buildings in which we live and work are built in a way that allows them to resume operations as quickly as possible. We refer to this as functional recovery. We'll talk to design professionals and owners who've incorporated resilience into the design and construction of new buildings. And we will show you how affordable resilient design can actually be. Building owners are achieving immediate returns on investment as their buildings are being rewarded for resilient design. And they are protecting their assets and business income against the big one, when, not if, it hits. Recapping from our first episode, structural engineering experts talked about the limited objectives of building codes and the misconception that buildings built to modern codes are earthquake and disaster proof.
That's the problem throughout the Western world. The building codes are all based on a premise of providing life safety, not damage-free. Now, most of the public and our architectural colleagues believe when they hire a competent structural engineer and get a building designed to code, quote, are getting an earthquake-proof building. And that's not what the profession is delivering.
We also introduced the concept of performance-based design in engineering, an approach that allows engineers to design buildings that deliver more than just life safety.
So the biggest innovation, the thing that's going on, is our ability to directly model performance in buildings. Like, we can take real earthquakes, build virtual buildings, and shake them, see what happens, predict like where they break, how they break. So 20 years ago, all the design objectives were around like safety. We kind of like solved the primary problem, which is don't kill anybody. But then now we have all these kind of secondary problems, which is like day after the earthquake, I can't get back in my building. Day after the earthquake, I don't have a place to live or I don't have a place to work. All of those issues are those are the ones that are left. So once you can describe building behavior and risk in terms of like basic understandable phenomena, damage, downtime, and safety, then owners now are just as empowered as engineers. Owners can get it. Owners can decide for themselves what they want, what they can afford, what they choose to pay for, how they allocate resources.
In hundreds of projects in places at risk of earthquakes in the U.S. and around the world, structural engineers and architects are using performance-based design to deliver resilient buildings to clients in both the public and private sectors. Clients are investing in resilience as a way to protect their investment, their business, the livelihoods of their employees, and the services they provide to their customers. Projects are successful when the entire design team works with the owner or users of the building from the beginning of the project to incorporate resilience features into the building. In 2015, the state of Oregon decided to construct a new 2-story facility to house its Treasury Department. The critical work Treasury employees do every day to manage the state's money and ensure payments are timely made can't stop when there's a disaster. Whether wildfires, volcanoes, or a magnitude 9 mega earthquake in the Cascadia subduction zone, the Treasury building needs to remain operational during and after an event. The state developed criteria the new Treasury building would have to meet in order to be confident it would function uninterrupted after a major natural disaster. They required that the building be designed to meet the U.S. Resiliency Council's highest standard of performance, a platinum rating. I talked with several members of the project's design team and with the Treasury Department about why resilience was important to the state for this project and how it was successfully integrated into the design. So let's start off maybe talking a little bit about the genesis of this project. Byron, why did the state feel it needed a new Treasury building? Who's going to work in the building? And why does the state consider it to be sort of an essential type facility?
So about 6 years ago, there started to be a lot more press in Oregon regarding the risks to Oregonians from a Cascadia earthquake. And prior to that, a lot of people didn't really think of Oregon as a high earthquake risk area. The treasurer is a statewide elected official that's responsible for overseeing the state's banking, debt management, and investment activities. And so in this last year, we processed just almost $300 billion in banking transactions on behalf of the state. We need to, on a day-to-day basis, make sure we are providing those critical functions to Oregonians.
One of the things that we've been talking about in this series is how building codes, even modern building codes, codes that we use today to design typical buildings, are primarily designed for life safety. But then also in the event of a large natural disaster, whether it's an earthquake or a hurricane, that the building will be safe, but not necessarily damage-free. Buildings that are built to sort of the minimum requirements of the code might suffer significant damage. Maybe they won't be economical to repair. Maybe it will take months or years even for them to be repaired if they are.
So when we first started looking at this, our initial analysis was looking at our current building and what does it take to make this building more functional for what we needed going forward. And as we started looking at that and doing the risk assessment, it's really when we started to realize the level of risk that we had in the current building. It wasn't just about making sure we had a building built to building codes or that it was built to the building codes for an essential facility. We wanted to make sure that we were getting to that immediate occupancy and operational level and making sure that it wasn't just that life safety, that our staff were safe. The impacts to Oregonians, if we were to have to go a month without sending out banking activities, would be catastrophic on its own.
Craig, as a full team of architects, structural engineers, but also mechanical, electrical engineers, how did you sort of establish that kind of communications back and forth with Byron and his team that had to talk about these issues of performance and how that might affect the design of the building?
Well, it started with a lot of good planning, and BlueMac engineers and KPFF structural engineers were involved maybe a year prior to GBD. When we formalized the team, we came on board, we got the entire team, all the stakeholders, not just the major designers, but civil and landscape and acoustical engineers, and talked about expectations. And out of the gate, the driving guiding principle, number one, was USRC Platinum, a building that could be readily reoccupiable after a major Cascadian quake without significant damage.
That's wonderful. So Reed, let's talk nuts and bolts here, or beams and columns. How did you design this building? What is its structural system? How would that maybe be different from sort of an ordinary office building, that might be in downtown Portland or something like that?
In the early stages of the process, we actually looked and worked together to look at different solutions. The first being creating a lateral force resisting system, the part of the structure that resists earthquake and also wind, building it out of a buckling restrained brace frame, which is a common lateral force resisting system type for steel frame buildings. And what we were finding when we started evaluating it against the USRC metrics, specifically safety, damage, and recovery, is that it had a hard time meeting that recovery dimension. And safety, obviously extremely important, and reducing the damage in a building is a key point. But when we're talking about resilience, we have found that a lot of times the discussion starts to center really more around recovery. And it's quite actually, I won't say easy, but straightforward to design a structure, meaning the portion of the structure, the portion of the building that is composed of beams and columns, not the things in it, for a very high performance level.
So how important is it to the whole design team that all of these discussions are laid out, the expectations for the building, and that everybody sort of have a seat at the table in the beginning so that the project is proceeding in a way that doesn't cause unexpected, challenges?
Well, we did start out with all the key stakeholders I alluded to in the room at the same time. We all put out what our goals were, and the base isolation and the USRC Platinum was really easy to work towards once we knew that was a prerequisite, essentially. And being able to know that really day one made our process much more efficient. We would have needed to go really back to the drawing board if we had found out that later in the design process, because it affects every discipline in the building.
So Byron, you talked about this a little bit in the beginning, but what are the kinds of payoffs that the state believes it's going to be getting from having this Treasury building be resilient, be base isolated, be operational, even after that mega quake?
I think for us, it's really about making sure that we are providing the services that are necessary and expected from our team. That we realize that we serve a critical function in the state that often is invisible to people. You don't think about it. I like to use, with my team, I use the analogy of, I say we're the wheels on the bus. Nobody thinks about the wheels on the school bus until they fall off. And then everybody's really upset that they fell off.
Well, I don't think any of us is unaware now about manufacturing PPE or ventilators or the process for producing vaccines, something that we all have intended to, we've all essentially ignored for most of our lives. And now, you see when it's needed, it comes to the forefront. Craig, the state brought the contractor in early on in the project during the design phase when they brought you in. Sometimes on a project, the design team works together, they get the whole project done, they get the drawings completed, and then it goes out to bid, and the first time a contractor sees it is when it's presumably all done from the design perspective. So having the contractor in early specifically to help figure out costs so that they could, dynamically determine kind of what in the wish list they could keep in the building. How did that process go for you and the design team working with a contractor early on in the project?
It was a welcomed process, especially with Pence Construction. They were a team member from the very beginning. Although the property owner went out to several contractors, they selected from the most competitive and most qualified contractor. We worked with them closely throughout the design process. They gave us feedback, they listened in, they went back to their sub-consultants and were able to comment on the design process throughout and talking about getting us the biggest bang for the buck as far as design features and what were practical and something that we could afford.
So Reed, what were some of the lessons you learned in this project? In particular, about the role the structural engineer has in ensuring a successful and resilient design?
I think the role of the structural engineer as an advisor to the owner and to the architect is something that is very important and a critical role that we can serve as structural engineers and as sort of resilience professionals. Oftentimes we have the technical capabilities and both to solve the problems, but not always to communicate them. And I think that it's important that really nothing can be done. A project like this and resilience in general can't be achieved in a silo. It's very much not just about the structure. And it's not even just about what the structure can do to protect the non-structural elements. As both Craig and Byron talked about, it's everything. It's the whole package in order to get to that resilience end goal. And I think one of the lessons that we can learn from this project is the benefit of bringing everyone together and having everyone engaged towards a central guiding principle.
Let's turn to a different kind of building with a different tenant population. Housing is a critical element in the ability of our communities to bounce back and recover after a natural disaster. What can performance-based design do for preserving housing, including our most vulnerable populations? I talked to Lori Schumann, Director of Climate Change, Risk Reduction, Resiliency, and Housing at Enterprise Community Partners, about why it's so important to address housing.
What we always want to do is keep people in their home. And on the same token, what we always want to do is mitigate risk to these homes. Because again, we know once a person's out of their home and displaced, it's very hard to come back. It's very hard to repair it. It's much more expensive. And so we see this again and again throughout the nation, whether it's up in Paradise, whether it's on a reservation, whether it's in the Keys, that housing must be preserved in order to keep the communities together.
As difficult as it'll be for individuals who have to live through this kind of hardship, it's even more difficult to imagine the effects on a community scale. A 2019 article in the Los Angeles Times predicted that a large earthquake in the LA Basin or the San Francisco Bay Area could leave more than 250,000 residents without habitable homes. Henry Burton is a professor of structural engineering at UCLA and has been studying how cities can measure the benefits of resilient design, particularly as it relates to housing.
Going back to this theme of our building codes and the focus on safety, but if we don't focus on usability or repairability, that could be a potential scenario, meaning you have a major earthquake in an urban center like Los Angeles, where we don't expect the number of fatalities to be very high, but you could foresee a situation where a large or some percentage of the population are not able to reoccupy their homes after the earthquake. And in that case, they'll look to temporary shelter. And if there's a strain on sort of the temporary housing that the city is providing, then you will have some percentage of what we call out-migration, meaning some fraction of the population that permanently leaves the city.
In a previous episode, we met David Marr, a structural engineer in Berkeley, California. His firm recently completed an apartment building, Casa Adelante, that will provide the highest levels of performance for low-income seniors in San Francisco. I had the chance to catch up with David about that project at the National Earthquake Conference in San Diego last spring.
It's a 9-story building. It's 100% affordable housing designated for seniors. 25% of the units are designated for formerly homeless.
I think seniors are, by definition, resilient. They've lived many, many, many years, had many, many struggles. We know that the stories, the individual stories of these seniors, there's a lot of strength there. And they're still, at that age, they're still facing big hurdles because most of them were afraid of being displaced like many other people had been here in this neighborhood. It's really important that we take care of them and provide them with the housing to live with dignity.
And so this building is for seniors, not only so that we can care for them as they age in place, but so that we can provide a stable platform from which they can continue to lead the city, and we're deeply appreciative of that.
If you think of the population, the folks in this building, they don't have extra money, they can't go to hotels after an earthquake. And so the dynamic here is that there's a both kind of need, opportunity to make a building that's more resilient, that allows folks to kind of stay in their homes while repairs are happening.
And what did you do to make this building more resilient?
We collaborated with a professor from New Zealand, Jeff Rogers. He fabricated and developed this lead extrusion damper for us, and we embedded the damper kind of in the foundation. So when the walls take the big earthquake hit, the foundation rocks, the damper gets activated, energy comes out, and then the weight of the building helps recenter it. It's exactly a shock absorber. I mean, same like technologies that you have in cars, and since you have springs, shock absorbers, and then a bumpy road, you got an earthquake. You got an earthquake, which is the bumpy road, and then building has stiffness and building has energy absorption.
So in terms of performance, how do you expect this building to behave in an earthquake?
So the performance expectations are that the structure is going to be fine. The structural damage will be sort of limited and repairable, and won't impede people staying in the building. We want to be able to keep people in their homes while repairs are going on.
David told me that the additional cost of installing the dampers in the building to improve its performance cost only about $100,000 on a $42 million project.
The number is like 0.24% extra. Early on, we're working with the developers. We did initial studies where we had the promise of cost neutral, then got green lighted to try the performance-based design, and then worked really hard to keep to the cost neutral. So the developers are happy that they think this is a worthwhile investment.
Casa Adelante recently held a virtual grand opening to celebrate the completion of the project. The developer praised the design team, specifically mentioning the structural engineer and the value of the USRC rating that the building received.
We and the entire team are really excited to do innovation and resilience for affordable housing. We're super excited with the results. This is the first project to receive a gold rating from the U.S. Resilience Council. We feel that it's a great precedent for achieving low-cost resilience, and we hope it's the first of many to come.
So, for an additional 0.25% investment in the construction, Casa Adelante went from an ordinary building to one that means the city will not have to provide additional shelter space to house its occupants after a repeat of the 1906 earthquake. One thing we know about the occurrence of natural disasters, it's a matter of when, not if. As long as we build in areas prone to earthquakes, hurricanes, wildfires, floods, or other hazards, we must accept the reality that one day our structures will be tested. And if they fail to meet that test, it will cost lives and also livelihoods. The buildings we profiled were designed to achieve resilient performance beyond the minimum requirements of the building code. The return on investment can be high. For the Oregon Treasury building, the state can count on the building remaining operational during those critical hours and days following a megaquake. The collaboration of the design team with the developer, the user, and the contractor was essential in creating a design that was both affordable and which would achieve the state's objectives. For Casa Adelante, the return is in the bank. When the big one hits, the city of San Francisco will have the confidence that its residents will have a safe place to stay, reducing the demands on the city's emergency services. And the apartment's owner will be able to maintain its source of income. It took decades for car manufacturers to put seatbelts in their automobiles, and decades more to put in airbags. But now no one would even consider buying one that didn't have both. Each time we decide to construct a new building, we have the opportunity to make our businesses and our communities stronger, safer, and better able to recover from natural hazard events. Building resiliently is good business. A small investment now, sometimes it means just writing earthquake performance goals into your project requirements and hiring an engineer who understands performance-based design, can protect your most precious and valuable assets, the continuity of your business, and contribute to the welfare of your employees, your residents, and the region. Next time on the Resilience Advantage, we'll consider how our communities benefit from resilient design, preserving both the social fabric of the places we call home and the financial stability that drive our economic vitality. We'll discuss how both the public and private sector are making resilience happen in cities across California, and what type of incentives are being offered to make resilient design a reality. Thank you for watching, and please join us next time on the Resilience Advantage.